Hi guys, welcome to the lesson of partial differential equations. So today we will learn how to form differential equations and how to form the different partial differential equations by eliminating the constants and eliminating the arbitrary functions. So we will take some examples, and before embarking into the questions, I will introduce some notations, that is dawa z over dawa x. We can write it as small p, and dawa z over dawa y, we can write it as small q. So we will use these notations in the later stages when we will solve some examples. So let's take a simple example. Perhaps it's the simplest example. I can say it's z is equals to ax plus b times y plus a squared plus b squared. So now we can see that we have constants a and b in the equation, so we have to eliminate these constants by using the partial differential. So I will differentiate the equation with respect to x. So what I get is a, and this will be 0, this will be 0, and this will also be 0. So this implies that my dz over dx is equals to a. And now again I will differentiate with respect to y, and what I get is b plus 0 and 0. Similarly, it will be dz over dy is equals to b. So now I can replace uh, this dz over dx in the place of a, and dz over dy in place of b. So now I can write it as z is equals to dawa z over dawa x times x plus dawa z over dawa y times y plus, and instead of a square I will write dawa z over dawa x whole squared plus, and instead of b I will write dawa z over dawa y whole squared. So now we can see that the constants have been removed, and we are only left with x, y's, the functions of x, y, z, and the partial derivatives. And as I told you guys before, that I can write p in place of dz over dx, so I will write it as xp plus, and in place of this I will write small q, so it will be yq plus. Now this will be p squared, because this is p and it's whole squared, so it will be p squared plus q squared. So this is our partial differential equation we formed by eliminating the arbitrary functions, arbitrary constants a and b. So now we will talk about some other example. So we will move on another example. Let's take a question, and it's z equals to x minus a squared plus y minus b squared. Now we can see that the constant a and b are with the variables x and y in the brackets. So now it's simple, and we can follow the same steps, that is dawa z over dawa x. What we will get is 2 multiplied by x minus a, and this will be 0. So this implies that our p, small p, because this is p, this is a small p, so small p is equals to 2 times x minus a. And again dawa z over dawa y is equals to 2 multiplied by y minus b. This implies that our small q is equals to 2 multiplied by y minus b. So this is small q. So now we can see that this is 2 multiplied by y minus b, but here we have y minus b whole squared. So if I squared this, like q squared is equals to 2 multiplied by y minus b whole squared, so I will get y minus b squared. So this implies that this y minus b squared will be equals to q squared divided by 4. So now I can replace this y minus b whole squared by q squared over 4, and similarly p squared will be equals to 4 times x minus a squared. This implies that x minus a squared can be replaced by p squared over 4. Now I will put this p square over 4 and q square over 4 in the original equation, that is equation number 1, and what I will get is z is equals to p squared over 4 plus q squared over 4, and this implies that p squared plus q squared is equals to 4z. So this is our partial differential equation. So you see that we can form partial differential equations by removing, or we can say eliminating, the constants, that is a, b, and maybe in some other cases more than a and b, maybe it will be c and d. So we are just eliminating the constants to form PDEs. So now we will take some examples of PDEs, like we have to remove the arbitrary function. So we will be given an arbitrary function, and I will write here what are these arbitrary functions. So let's take an example of an arbitrary function. Let's say we are given a question that z is equals to function of x squared plus y squared. Now we can see we are given a function, and we don't know what the function actually is. It may be like e to the power x squared plus y squared. It may be like e to the power sine of x squared plus y squared. It may be like ln x squared plus y squared. So it may be like any function of x squared plus y squared, any function which has x squared plus y squared, but we don't know what that is, what that actually is. So what we will do is the same. We will differentiate partially with x first, and now when I will differentiate this function with respect to x, what I will get is, I will first of all I will get the derivative of the function, that is f prime of x squared plus y squared, and then multiplied by dawa over dawa x times x squared plus y squared. That is same as we did in the case of ordinary differential equations. It's similar to that. For example, let's take this function. Let's say e to the power x squared plus y squared, and I want to differentiate this function partially with respect to y. So what I get is e to the power x squared plus y squared times the derivative of this x squared plus y squared. So now here I cannot write any function because I don't know what the function actually is, so I just write it is the derivative of the function. So it's the simple way to express this. Now what will be the partial derivative of this function? It will be 2x multiplied by the f prime of the function, that is f prime, that is the derivative of the function. So dz over dx is equals to 2x times the first partial derivative of x. Now similarly for dz over dy, we will differentiate the function partially, and we will get again something like this function prime multiplied by the partial derivative with respect to y of the inside function. So now dz over dy is equals to, this will be 2y because we are differentiating with respect to y, so it will be 2y multiplied by f prime of x squared plus y squared. Now what we have to do is we have to remove this arbitrary function, so we have to remove this f or f prime of x squared plus y squared because we don't know what actually this is. So to remove this, if I divide this equation, let's say this is equation number 1 and this is equation number 2, and if I divide this equation number 1 by equation number 2, so I can cancel this f prime of x squared plus y squared and f prime of x squared plus y squared. So let's do that. So we will divide dawa z over dawa x is equals to, it will be divided by dawa z over dawa y, that is equals to 2 times x multiplied by f prime of x squared plus y squared, and it's divided by 2 times y f prime of x squared plus y squared. So now this will be cancel out, and what we will left with is implies that dawa z over dawa x divided by dawa z over dawa y is equals to 2x over 2y. So for dawa z over dawa x, I can write it as small p, and dawa z over dawa y, I can write it as small q. So it will become p over q, that is equals to x over y. So I can, this implies that I can write it as yp is equals to xq, and this implies that y times p minus x times q is equals to 0. So this is our partial differential equation from that arbitrary function which was given initially, that was function of x squared plus y squared. So you see how to solve these questions, and it's not a difficult task, you can solve it easily. Let's take another example so it will be more clear. So let's say we have a function of let's say we have a function that is z is equals to function of y divided by x. So what we will do is that is like same as we did in the previous example, that is dawa z over dawa x will be equals to dawa over dawa x multiplied by the function, and what we will get will be function prime, that is the derivative of the function, multiplied by dawa over dawa x multiplied by the function itself. So dawa z over dawa x will be equals to function prime y over x multiplied by, this will be differentiated with respect to x, so we will get negative y over x squared. So dawa z over dawa x will be equals to negative y over x squared times f prime of y over x. So we can box this to use in the later stages, and now we will find dawa z over dawa y. To find dawa z over dawa y, we will adopt the same procedure, so it will be dawa over dawa y times function of y over x, and this will give, this implies that dawa z over dawa y is equals to f prime of y over x multiplied by dawa over dawa y times y over x, that will be equals to function prime of y over x, and it will be equals to 1 over x. So you see now we have dawa z over dawa y, that is equals to 1 over x times f prime of y over x. Now similarly in this case also we have only one way to solve, that is we have to divide this function, so in order to remove this f prime of y over x. So we will divide this. This is basically small p and this is basically small q. So we can say p over q. So p over q will be equals to minus y over x squared over multiplied by a function of this will be 1 over x, function of x, y over x, and this is also function prime, sorry, function prime of y over x, and this is p over q. So now we can see that this will cancel out and this x will cancel with 1x, and we will left with p over q is equals to negative y over x. So this implies that the function is x times p, or you can write it px or x times p. Better is that you can write it x times p is equals to negative y times q, and we can write it as x times p plus y times q is equals to 0. So this is our partial differential equation. So now you see we can remove these arbitrary functions by first taking the partial derivatives and then dividing them to cancel their derivatives, and what we left with is only the terms of pq and xy. So you can practice some problems from the books, or you can, if you have any query, you can ask me in the comment box. Thank you for your time, guys.